Okay, so let's take a look at the second part of the pop quiz over here, right? Where we are using the substitution to solve this problem right here. Okay, so how do we go about this? Okay, yeah. So the first thing that we need to do when we want to do a um, integration by substitution, right? Remember, we need to sub in these three things. We need to change our limits, we need to change our expression, and we need to change our differential part. Okay, the dx part. Okay, so how do we do this? Now, on one side, you do x equals to root 13 sine theta, right? So what you do over here, you do dx d theta be root 13 cosine theta. So in illegally, you can write something like this. Okay, the illegal one. Okay, you can write something like this to be replaced into your differential. Okay, what is next to do? We need to also change our limits. Okay, so the limits over here, when x is equals to negative 3, right? Root 13 sine theta equals to negative 3. Sine theta is negative 3 over root 13. Theta would be equals to sine inverse 3 over root 13. So you can see that this is something that we have inside the answer. Okay, next, one more limit. When x is equals to 0, root 13 sine theta is equal to 0. So solving, right, theta will be equal to 0. Okay, so now let's do the integration finally. Okay, so starting from this one. Okay, so first one, let's change the limit. So from negative 3, change to sine inverse negative 3 over square root 13, right? The 0 replace with the 0. Okay, next one, 13 minus x squared, so become 13 sine square theta. Okay, then last but not least, the dx you change with this one. So dx, right, change with root 13 cos theta d theta. Okay, so when you change everything, make sure it's best to change everything at one go. Okay, change everything at one go so that you change all your limit, expression, and differential all together. Okay, also you need to double check that the angle that you get for theta, right, would be within this domain over here. Okay, so remember to double check and read again, check domain, check LED, and so on. Right, so now let's try to simplify and try our best to integrate. Okay, so this one inside over here, right, let's pull out the 13. When you factorize out the 13, right, it's actually root 13. Then over here we have 1 minus sine square theta. Then we have another root 13 cosine theta d theta, right? So then we can further simplify things out. So observe that this one over here we have 1 minus sine theta. I will change it to cosine square, and cosine square and the square root will cancel. So I will see something like this. Okay, and I add the cosine square and the square root. Nice. Okay, so now cosine square is a very, very nice thing to integrate. Okay, and the standard technique to integrate squares of a function, right, is to make use of our trigo formula, right? So for cos square, this one you remember, so cos 2 theta would be equal to 2 cos square theta minus 1. So making cosine square the subject, I will actually have half, okay, cosine 2 theta minus 1. Okay, I can actually express it like this. Sorry, plus 1. Okay, plus 1. Okay, and I think now it is time for us to integrate. Okay, how to integrate cosine 2 theta? Cosine 2 theta integrate to become sine 2 theta, reverse chain rule, divided by 2, plus 1 integrate become theta. limits, we keep the limits for our this one. Okay, now then the next thing is, right, for this question, do we need to change back to x? The answer is don't need, we just evaluate straight away. Okay, so now the thing is, let's take a look let's take a look at how do we handle this bit. Okay, first one, so when we sub in 0, okay, so sine of 0 is 0, sub in the theta, right, this one over here is going to be 0 as well. Okay, so this one over here, it would be 0. Okay, minus, okay, let's take a look. Now let's sub in this troublesome thing over here. Okay, so what we have, right, is, or maybe before we sub in, right, this 2 theta is a bit of a problem, right? This 2 theta is a bit of a problem. So if you notice, right, if we get something like this, okay, we get something like this first, and then plus this one. Okay. Okay, so one more thing that I need to point out is that minimally, as an A math student, right, you need to know at least until here. Right? You need to know all the way, right, until you integrate until here. Okay? For your substitution, right, you need to know this progress all the way until there. So this is the minimum that you need. Then, right, the subsequent part, right, actually come from experience and come from repetition, right? And then this one actually paying attention in lecture also. Then yeah, so this is something that you've seen in your lectures. So first, so then right now what we do is, let me expand this 13 over 2 and move the not so troublesome one in front. Okay, later I can shift it behind. Then I will minus, okay. Then I also have a minus 13 over 2. Now this one over here, right, is double angle, right? Sine 2 theta, right? So if you notice, sine 2 theta is 2 sine theta cos theta, right? So what I can do is going to be like this, right? So it becomes times, okay, 2 sine theta, okay, cosine theta. Okay, so hope you can see this. Now, then let's try to evaluate. This one I keep here first. Okay, also take cue from the what do you call that, the question to know where you're going. And from the question, right, you can, at this point you can see that you have this one already. This one is done, right? And A is that constant that we still need to find from here. Okay, so first one over here, these 2 and 2 will cancel, we get then the sine and sine inverse, right, inverse function, so they will also cancel, so I get a 13 and a negative, okay, then negative will become okay, never mind, one by one. Okay, so something like this. Okay, now then this one is the problem. Okay, this one over here is the problem. Now how do we evaluate cosine of sine inverse of this? Okay, so let's take a look. For this one over here, right, there is a special technique also. In order for us to get the exact value, we need to construct a right angle triangle, right? So what is sine inverse of this, right? This is actually an angle, correct? This is an angle. So this means that sine theta will give us negative 3 over the root 13. Okay, so based on this, right, let's construct a right angle triangle over here, right? So imagine if this is theta, the opposite is 3, the hypo is root 13, right? And I think at this point, right, you can do your Pythagoras right? And then this one over here is going to be root 4. So root 4 over here, right, this one will give us 2. So this h over here is 2. So this means, right, what is cosine of this angle? So the cosine of whatever this angle, right, is going to be adjacent over hypo. Okay, it's going to be adjacent over hypo. Now, then if you think about it, right, if you think about this and the domain, okay, this one over here, right, is actually in quadrant 4. And in quadrant 4, right, cosine of this angle is going to be positive. Okay, so this one's something for you to take note, another detail to take note. So because of this, right, this cosine of whatever this angle is, right, is going to be positive 2 over root 13. Okay, and so because of this, okay, we can try to simplify this. Okay, so now root 13 and the 13 in the denominator can go together. Then this one will be plus 6. So altogether 6 minus 13 over 2 sine inverse of negative 3 over root 13. And they want us to find a, right? So over here we can also declare that where a is equals to 6. Okay, at this point is also my bad. I forgot about this divide by 2. So I have a half over here. Okay, and actually I have another half over here. I have another half over here. And then this one over here, right, it should be 3. Okay, because this run, right, the 2 and these 2 can cancel. So at the end of the day, I should have a 3 over here, and where a is equals to 3. Okay, so this one my bad. Okay, so this one just be careful. I forgot my half. Okay, so that is for part 1 of the second of the question in the pop quiz. Okay, and then I think we can continue to take a look at part 2 of that pop quiz. Okay, so part 2 of the pop quiz, right, would look something like this, right? We have a circle over here. The diagram shows the region A, which is bounded by a circle with equation, and the region B is bounded by a circle, line, and y-axis. Okay, so using part 1, right, using the results from part 1, find the exact area of A. Oh yes, I almost forgot. So we also want to look at the mark scheme, right, for assessment literacy for this question over here. Now, so usually, right, the first few marks will go into the substitution step. Okay, so over here, right, we will encounter 2 substitution steps. The first one is when you change your limit. Okay, then this one over here is when you change your expression and the differential. Okay, because change expression, very easy one. But a lot of students tend to forget about the dx or the differential. Okay, so it's not just dx change to d theta. Your dx, right, you must differentiate to get your d theta. Okay, so this one take note. Now then the third mark will come at this point. Your integration technique for cosine square. Okay, and the integration technique is to change it to double angle so that you can integrate this using your A math. Okay, now so far this is how many marks again? This one over here is 5 marks. So the 2 more marks come from here. Now 1 more mark, right, is a bit vague. So sometimes you will see that 1 more mark is given to the substitution. Now sometimes, right, for this particular pop quiz, right, the 1 more mark actually come from here. How you handle this part. Okay, how you handle this thing over here. This very annoying thing over here. Okay, or let's say if you want to be a bit lenient, then how do you do your substitution over here? Okay, because then it will reveal this part over here, which is very easy. Then last but not least, the final answer for this one over here. Okay, so it actually depends on how strict or what kind of marks will go. So the second last mark, right, will either give you for this or will either give you for this. okay, depending on the mark scheme set out by the examiner in the real exam. Okay, so this would be for the first part. Now, moving on to the second part again. Now, using part 1, find the exact area of A. Now, so for A, right, we need to determine whether is this what do you call this um, dx or a dy. Okay, but they ask us to look for use part 1, right? Part 1 over here asks us to dx leh. So actually no choice lor but to dx lor. So let's find out what is this. We need to split this into two parts. We got the area 1 and area 2 over here. Okay, then we need to integrate from where to where, right? So let's use our GC, okay, and to find what is these two intersection points over here. Okay, in your GC, right, your intersection point would be to -3 and 3, and this one over here is 2 and 8. Okay, this means, and then if you were to do this, right, when when y equals to 0, x would be -6. So essentially we're integrating from -6 to -3 and from -3 to 0 lah. Okay, if you were to see this, so the exact area A over here, right? Okay, so this one would be area A would be equals to, now this triangle over here, or maybe we state our intersection point first. Okay, so from GC, okay, intersection between circle and line. Okay, so we state this first. So the area of region A. Okay, if you observe this from -6 to -3, right? So it's either you do this integration or this is a triangle. So half times base times height plus integrate from -3 to 0 of this curve over here. Okay, of this curve over here. And in this curve, right, let us try to decide whether do we take the positive or the negative curve. So making y the subject, because we want dx, right? When we make y the subject, it will look something like this. Okay, now then, right, if you notice over here, now for this particular one over here, right, is actually the bottom half of the graph. So for the bottom half of the graph, right, if you notice, this is 5 minus a number over here, right? So it will follow this equation. It's lower than 5, so this one is going to be a 5 minus something, okay, for this graph. Whereas if you notice, right, the next thing to notice is for this one, this is a 5 plus something graph, so it will form the positive half, the on top part of the graph. Okay, can so which curve do we use for the region over here? The curve that we use for this region is going to be the negative curve. Okay, so this would be 5 minus 13 minus x squared, then dx. Okay, so this one take note. Okay, take note. At this point over here, you will get your B1 mark for the correct limit and the correct for the correct limit and the correct expression. Okay, that we need to integrate. Okay, so let's do one by one. Next, half times 3 times 3, 9 over 2. Okay, integrating 5 will give me x. Okay, from -3 to 0. Okay, now integrating this one, right, over here, this one from the earlier part, we actually have this plus, okay, sorry, okay, this one over here, this one is 5x. Okay, then so this one over here, right, I will have a minus, okay, minus 3 minus 13 over 2 sine inverse of negative this one over here. Okay, now then I will have 9 over 2 plus 0 minus minus 15. Okay, then we can simplify all the numbers outside. and we'll see a 33/2. Okay, plus whatever that's at the back. Okay, so that's for part number 2. Okay, so once again, take note for this question, we want to find exact value for the area A. Okay, now for in part 3, we want to find the volume of revolution when B is rotated completely. Okay, take a look. We have rotated completely about the y-axis. So this means that we will need to do a dy. Then the best part is we can give our answer correct to 3 significant figures, which means that this one we can make use of our GC. So our job is to define the integral correctly. Okay, so how do we go about this? Okay, also because we are doing dy, right? So maybe let's change the perspective a little bit. So instead of making y the subject as like just now let's try to make x the subject. Okay, and let's see what our functions are. Okay, so over here, right, or maybe x squared would be a good subject then. Okay, since, yeah, okay, something like this. Okay, actually we don't really need to make x the subject because it will be pi x squared dy. Okay. Okay, so now let's visualize, right, roughly what should we do over here. So we have this big area that we can rotate around, right? However, we need to, okay, so however, right, we need to minus off this part over here. We need to minus off this part over here that would be governed by this region. Okay, we need to minus off this part over here. Okay, one more thing to take note is from where to where, we also need to find out where are these points over here. Right, so making use of this equation line, the y-intercept is at 6. Okay, then for this one over here, making use of the equation of circle when x is equals to 0, okay, then you can try to find the value of y, or if you think about this one over here, right, the center is 5, 0. Right? So if the center is 5, radius is root 13. So over here, right, this one over here is actually 5 minus square root 13. Okay, so I think now we are ready to do the integration over here. Okay, so our volume of region B, okay, so this one is going to be, okay, this one take note, volume is pi x squared dy or pi y squared dx. Okay, so volume of region B, right? Okay, so first one, we are going to integrate from 5 minus root 13 all the way to 8. Okay, take the y value from here all the way to here under this curve, okay, of x squared dy. So the x squared, which is over here, is 13 minus y minus 5 square dy. Okay, then I need to minus off the area, the volume generated from this region, right? So from 6 to 8, right? And the curve that is in this region, right, is actually this curve, which is the equation of line. So over here, make x the subject. So this one would be, make x the subject. So this is y minus 6 dy. Okay, or pi y square. Okay, pi y square dx. And pi x square dy. Okay, remember, don't forget your square. Okay, so this one be very careful. Don't forget the pi, don't forget the square. Okay, so this one indeed is already x squared. Okay, so then because right our final answer is 3SF, right, just pump this into GC, it will roughly give you about 184 units cube. Okay, now then let's take a look at how do we get the marks, right, from the previous parts. Over here, okay, B1 for this, okay, the 2 more marks, right, is actually for this okay, to piece everything together. Okay, the rectangle plus the area under the curve. Okay, then last but not least is actually the final answer. Then for part 3, where will your 3 marks go? Okay, your 2 marks will come each for your integral, or you may take a bigger volume minus smaller volume as 1 mark, and then the correct formula as another mark, right? So so this one, right, is flexible for the examiner to mark, right? Last but not least, 184 as the final answer. Okay, so hope this video helps you to understand better on the needs for your integration application lah, especially your area and the volume of revolution. So all the best and good luck.